Good morning, dear students. I am your physics professor, Dr. Nagaraj. I have already uploaded several videos on engineering physics as well as PUC physics. With this video, I am going to start a new series of lecture videos, YouTube videos, once again physics only, but it is for engineering students, exclusively for those who are studying in first and second semester of VTU, that is Visvesvaraya Technological University. So this lecture series will be in four different playlists, because you know there are four different streams: engineering physics for civil engineering, applied physics for civil engineering, applied physics for computer science and engineering and allied branches, applied physics for electrical and electronics allied branches, and applied physics for mechanical engineering and allied branches. Like this, VTU has designed four physics syllabus for different streams. It is actually called stream specific syllabus. Of course, it is already known to you, and it is same even in chemistry also, mathematics also. Anyway, already some of my videos are available in my channel, especially for computer science students and electrical and electronics allied branches students. I have already uploaded several videos. Anyway, so here onwards I will make playlist and for separate stream like CSE stream or EE stream or CV stream or ME stream, like that. So I hope these videos are going to be helpful and useful to you, and I am going to upload even PDF of my notes, and if possible previous year question papers along with solved numerical problems and answers. Dear students, here while teaching I might be using some Kannada words in between. That doesn't mean that I am explaining full thing in Kannada only so that other students are unable to follow. I am explaining whatever I am explaining in English, same thing I am explaining in Kannada also, for the benefit of those who studied up to 10th standard in Kannada medium. Kannada medium alli ಓದಿರೋರಿಗೆ ಸ್ವಲ್ಪ ಅನುಕೂಲ ಆಗಲಿ ಅಂತ ಹೇಳಿ here and there I will be using Kannada words, but that doesn't come in the way of understanding the whole content of the chapters or whole content of the video. So if I use Kannada, those who don't know Kannada, because in our state in engineering colleges other state students are also studying, they may not be comfortable with this Kannada language. So for the benefit of such students, I am teaching in English and these videos are going to be helpful. ಜೊತೆಗೆ ನಮ್ಮ ಕರ್ನಾಟಕದ ವಿದ್ಯಾರ್ಥಿಗಳಿಗೆ ಅನುಕೂಲ ಆಗಲಿ ಅಂತ ಹೇಳಿ ಮಧ್ಯದಲ್ಲಿ ಕನ್ನಡ ಕೂಡ ಯೂಸ್ ಮಾಡ್ತೀನಿ. So my intention is my videos should serve the purpose of all the students. It should cater the requirements of all engineering students studying under VTU, Visvesvaraya Technological University. Well, dear students, with this, now today I am going to start with first module of computer science and engineering. See, some of the chapters are common in computer science and electrical electronics. So physics, there are totally 5 modules. Already you might be having syllabus copy with you. If not, syllabus is available in VTU website. So first and foremost thing what you have to do, go visit VTU website, download the syllabus. Okay, so check module wise. So in each syllabus, whether it is computer science or electrical or civil or mechanical stream, there are totally 5 modules, and some of the modules are common in computer science, electrical, electronics. Similarly, some of the modules are common in civil and mechanical. For example, in computer science we have laser and optical fiber. Even in electrical allied branches also we have laser and optical fiber. Like that, we have modern physics or quantum mechanics in computer science stream. We have modern physics even in electrical stream also, like this. So some of the topics are common. Anyway, I will upload the videos stream wise only. Well, so this video I am starting with laser and optical fiber. As I said few minutes back, it is for computer science and engineering students, but some of the videos are useful even for electrical science also. Well, dear students, with this I am going to start with module 1. So the chapters are named after modules. So first module is nothing but laser and optical fiber. So it is laser and optical fiber. Okay, so first we shall discuss about laser, afterwards it is optical fiber. Okay, so as usual, before starting any chapter I would like to give some brief historical developments of that particular concept. So first I talk about historical developments of laser. Okay, laser. What is actually laser? You know, laser is a short form, form of light amplification by stimulated emission of radiation. So it is light L, amplification A by stimulated S, emission E, radiation R, that is LASER, laser. I think you are studying laser for the first time in detail in your curriculum in engineering. I don't think you studied laser in PU or high school. You might have heard of laser, but not in detail. Okay, what actually laser, how it works, how to produce, what are the applications, what are the properties of laser, all these things you might not have studied. Anyway, so in this module we are going to study about properties of laser, how it is different from ordinary light, how to produce laser, what are the applications, all these things we are going to study. So as I told just now, laser stands for light amplification by stimulated emission of radiation. Before I go ahead with the explanation of laser, let me talk a little bit about the history of laser. See, laser is a highly powerful beam. It is nothing but light beam. Highly powerful. Highly powerful means how much, sir? You cannot compare with ordinary light at all. See, just one or two comparisons I would like to give. If you switch on the torch, the light travels maybe about 50 meter and vanishes. If you switch on laser beam, okay, if you switch on laser source, it will travel several kilometers of distance. So strong it is. So it can travel in a narrow path, collimated path. Next, if you switch on the light and if you illuminate your hand will not suffer any problem. That means it will not produce any heat on your hand. You can even look at the light. See, I have light here, I can stare the light. My eyes will not be strained. And kandige strain agodilla. But if you look at the laser will cause problem. It may cause some problem to the retina. It may burn your retina. Some lasers are so powerful that they can burn your skin also. So that is the power of laser. In fact, we have lasers which can be used to cut metal sheets. We can use laser to cut the cloth. We can use laser to drill holes in the metals, or welding purpose we can use laser. So powerful the laser beam is. So now the question is, how laser is different from ordinary light and why it is so different? Before getting answer for all these questions, let us look at the historical developments of laser. First of all, idea of laser was given by Einstein way back in 1917. Dear students, you need not have to worry about history of any particular topic, but my habit is, without mentioning the efforts or historical developments, effort put by scientists for developing that particular concept, if we start only the topic directly, it is a sort of injustice. This is what I feel. And also, if we know the effort of scientists behind developing the topic, then we also may get motivated and also we get some interest in the topic. This is the main reason why I talk about history always whenever talk about particular topic. Same thing happens even in case of optical fiber also. So ನಾನು ಯಾವುದೇ ಹೇಳಿದ್ರು ಕೂಡ ಮೊದಲಿಗೆ ಒಂದು ಸ್ವಲ್ಪ ಹಿಸ್ಟರಿ ಹೇಳಿ ಮುಂದೆ ಹೋಗ್ತೀನಿ. ನೀವು ಹಿಸ್ಟರಿ ಬಗ್ಗೆ ಕ್ವಶನ್ಸ್ ಬರುತ್ತೆ ಅಂತ ತಲೆ ಕೆಡಿಸ್ಕೋಬೇಡಿ, ಬರೋದಿಲ್ಲ. ಹೂ ಡಿಸ್ಕವರ್ಡ್ ಲೇಸರ್ ಅಥವಾ ವಾಟ್ ಈಸ್ ಐನ್ಸ್ಟೀನ್, ವೆನ್ ಐನ್ಸ್ಟೀನ್ ಪ್ರಪೋಸಲ್ ಲೇಸರ್, ಇವೆಲ್ಲ ಏನು ಕೇಳೋದಿಲ್ಲ. ಬಟ್ ನಮಗೆ ಕುತೂಹಲ, ಸೊ ಕ್ಯೂರಿಯಾಸಿಟಿ, ದಟ್ಸ್ ವೈ ಐ ಆಮ್ ಟಾಕಿಂಗ್ ಲಿಟಲ್ ಬಿಟ್ ಅಬೌಟ್ history. Okay, way back in 1917, our well-known physicist, all-time genius Einstein, okay, so proposed the concept of stimulated emission. What is stimulated emission? We will learn later on. But look at this year 1917. It was a period of almost First World War. Nobody took it so seriously. Okay, after First World War, within no time Second World War also came, and people were busy in developing radars, developing aircraft, developing telephone conversation systems, communication systems, and also they were busy in developing nuclear bombs, chemical bombs. Athara, they diverted their research activity towards that side. So nobody gave so much importance to laser even after the end of Second World War also. But remember, way back in 1917 itself, Einstein gave the idea of laser, especially stimulated emission. Okay, after Second World War over, after everything settled down and then things became normal and life started moving as per the routine activities. That was in 1950s, maybe 51, 52. One fellow, one scientist by name C.H. Townes, okay, C.H. Townes reconsidered the concept of stimulated emission and extended it to practical or designing a particular device and came out with a setup called Maser, M-A-S-E-R, Maser. Maser stands for microwave, A stands for amplification by stimulated emission of radiation. So this is the beginning of working laser. Okay, actually it is not laser, it is microwave amplification by stimulated emission of radiation. And within no time, maybe 8 to 9 years, that was around 1960, T.H. Maiman, another physicist, came out with a laser device called Ruby laser. Okay, so this is the first working laser, Ruby laser. So this is the beginning of laser. And laser after 1960, within no time, that was in 1961, helium neon laser came out. And almost every year people started designing lasers of different type. Now today we have so many lasers around us. Okay, so like how lasers came in, even though the proposal was in 1917, it took almost 60 to 70 years for realizing the laser at common man level. So ಒಂದು 60-70 ವರ್ಷ ಆದಮೇಲೆ ಲೇಸರ್ಸ್ ಅನ್ನೋದು ಮನುಷ್ಯನಿಗೆ ಬಳಕೆಗೆ ಸಿಗಲಿಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆಯಿತು. ಹಾಗಾದರೆ ಈ ಲೇಸರ್ ಅನ್ನೋದು ಏನು, ಯಾವ ಥರ ಅದನ್ನು ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡ್ತಾರೆ, how actually the laser is produced. See dear students, laser today is available in market even for 50 rupees also, for 50 lakh also. See the diversity of laser. 50 ರೂಪಾಯಿಗೂ ಸಿಗುತ್ತೆ, 50 ಲಕ್ಷಕ್ಕೂ ಸಿಗುತ್ತೆ. ಅಂದರೆ we get laser for a cheap amount, even it is a costly item also. And laser is very light, maybe like a pen. Okay, and laser is big also, it can you cannot hold it in hand. Andre size wise it is very compact also, huge also. So two extreme ends. Okay, and lasers we have of milliwatt power, we have lasers of megawatt power also. That means we have lasers of 10 power minus 3 watt, we have lasers of 10 power 6 watt also. Okay, and we have lasers which can produce heat of 10 to the power of 6 Kelvin. That means we using laser we can produce a temperature of 10 lakh Kelvin, and also using laser we can reduce the temperature to 10 power minus 6 Kelvin. See, two extremities I am talking. Okay, so we have laser which can produce a very high temperature, we have laser using which we can produce very low temperature, micro Kelvin also we can achieve. Okay, and today laser has grown into a trillion dollar industry. Just 60 years, in a span of 64 years, laser has grown into $1 trillion industry. Astu importance ide. You can find laser in almost every field, whether it is agriculture field, medical field, entertainment field, communication field, research and development, or biotechnology, ಯಾವ field, or defense, especially defense. Nowadays we are using laser very much in defense. Laser guided missiles anta, we have laser guided missiles including India. Laser is already used in defense. And laser range finder, okay, laser printer, okay, ನೀವೆಲ್ಲ ಪ್ರಿಂಟ್ ಔಟ್ ತಗೋತಿರಲ್ಲ, it is laser printer. And laser assisted memory storing devices, holographic memory storing devices, compact disc, using laser only we can write the data in CD. So many applications are there. And this laser, just believe it or not, was not there just 60 years back. So therefore I can say, if you list top 10 achievements of 20th century, definitely laser will find its place in that list. Maybe first one or second one, definitely not be and third one. So that shows how important laser is. Okay, with this now I go to properties of laser. First property, laser is highly monochromatic. Some of the terminologies I use are already known to you. For example, monochromatic. What is chromatic? Chromatic means color. Chromo means color. Mono means single color. Okay, so single color. Highly monochromatic means single wavelength. So that is first property. Of course we have even multichromatic lasers also, but monochromaticity is one of the speciality. Next, it is highly collimated. What do you mean by collimation? Collimated, just wait. Highly collimated. What do you mean by collimation? Traveling in the form of narrow beam. See, if this is the torch, okay, if you switch on, the light travels like this. Okay, so it gets dispersed this way. This is a torch, normal torch. If you have a laser source, if you switch on, it will travel in the form of narrow beam. Some lasers are so collimated, so powerful that even after traveling several thousands of kilometers, you won't see even 0.1% deviation also. ಸಾವಿರಾರು ಕಿಲೋಮೀಟರ್ ತನಕನೂ ಟ್ರಾವೆಲ್ ಮಾಡ್ತಕ್ಕಂಥ ಲೇಸರ್ಸ್ ಇದೆಯಂತೆ, ಅಷ್ಟು ಪವರ್ಫುಲ್ ಲೇಸರ್ಸ್ ಇದೆ. ಓಕೆ, ಸೊ ಇಟ್ ಈಸ್ ಹೈಲಿ ಕಾಲಿಮೇಟೆಡ್. ನೆಕ್ಸ್ಟ್, ವೆಲ್ polarized. What do you mean by polarization? That's what I said. Some of the terms are already known to you. For example, collimation. Okay, collimation, monochromatic, polarized, all these are known to you. Okay, polarized means in a beam there will be only one type of vibrations. If there are multiple vibrations like this, then it is not polarized. If there is only one type of vibration, then we call it as polarized. Next, lasers are having highest energy, highly energetic. Okay, in fact, using lasers we can cut diamond also. Diamond is one of the hardest element on the earth, but we can cut diamond using laser. We can drill holes in the diamond. I told you, no, we can weld metals using laser. We can cut cloth using laser. So laser welding, laser cutting, laser drilling, all these are possible because it is highly energetic. So these are the special properties, very exclusive properties of laser. Now, how to produce such type of laser beam? Okay, so these are all the special properties. It is monochromatic, collimated, polarized, energetic, and one more, it is coherent. What do you mean by coherency? See, if the wave is traveling like this, okay, I start from here. One wave is traveling like this, another wave is also traveling like this. Everywhere the waves are matching, then we call it as coherency. Means the path difference should be same. Everywhere path difference should be same. Then only we call it as coherent wave. Okay, so now with these properties, I now would like to mention the laser beam, and I compare laser beam with ordinary light. See, in ordinary light, we will be having all possible colors, all possible waves, all possible wavelengths. Okay, some waves are small, some waves are big, some waves are medium. So all possible wavelengths are there. This is ordinary light. Okay, this is in case of ordinary light. Suppose if it is monochromatic light, then only one color, only one wavelength like this, but the starting points may not be same. Okay, starting points will be different. See here, this length, okay, and this length are same. Okay, this length and this length is also same, but this wave is starting with the crest. Okay, and this is starting with the trough, and this is starting with partial crest. So starting points are not same. So I can at most call it as monochromatic but not laser. Monochromatic means single color but not laser. I won't call it as laser. If I want to call it as laser, it should be like this. If one wave is like this, another wave also should be like this, another wave also should be like this, another wave also should be like this, andre their starting point must be same. So I can call this comfortably as laser. Okay, see the difference? Ordinary light, monochromatic light, laser, all these things are available in my notes. Please go through it. In ordinary light we have all possible wavelengths. Monochromatic only one wavelength, but the path difference is not constant, whereas here it is not only monochromatic, not only coherent, also well polarized, plus traveling in the same direction, So this is the laser representation. Now the question is how to produce such type of light. It is possible only through light amplification. Okay, amplification, you should understand this term. Amplification andre eno? By stimulated emission of radiation. This I already mentioned in the beginning. Now let us understand the two terms. One is amplification, another one is stimulated emission. Dear students, amplification is a very common name. Amplifier anta ನೀವು sound system ಅಲ್ಲಿ ಕೇಳಿರ್ತೀರಾ. Amplification means increasing the strength anta. So in case of voice, increasing the strength means increasing the intensity. ಈಗ ನಾನು ನಿಧಾನಕ್ಕೆ ಮಾತಾಡ್ತಾ ಇದ್ದೀನಿ, ಜೋರಾಗಿ ಮಾತಾಡ್ತೀನಿ ಅಂದ್ರೆ I am amplifying, I am increasing the intensity. So in case of sound, increasing the intensity is nothing but increasing the amplitude. For example, I have one wave like this. This is one wave. Another wave is like this. This is second wave. Definitely second wave amplitude is more than the first wave. So this is amplified wave. This is a amplified wave. So amplified andre amplification, amplifier, amplitude increase agide anta. So this is in case of sound. Now the question, in case of light, how do you achieve amplification? Very simple. Go back to Einstein's definition, Einstein's photoelectric effect. In PUC you studied. There he says intensity of the light depends on the number of photons. Einstein ಹೇಳ್ತಾನೆ, if more number of photons are emitted, intensity will be more anta. So intensity is directly proportional to photons anta. Nodi, see, this is what in between I will be using Kannada words, but definitely it will not affect the flow. Okay, ಕನ್ನಡದವರಿಗೂ ಅರ್ಥ ಆಗುತ್ತೆ, ನಾನ್ ಕನ್ನಡದವರಿಗೂ ಕೂಡ ಅರ್ಥ ಆಗುತ್ತೆ. They also can make out. So ಏನಕ್ಕೆ ಹೇಳ್ತಾ ಇದ್ದೀನಿ ಅಂದರೆ, because some students are putting their comments in the comment box. Sir, use only English, we are not able to follow Kannada ಅಂತ. ಬಟ್ ಮಕ್ಕಳೇ, ನಾನು ಹೇಳ್ತೀನಿ, ಕನ್ನಡದಲ್ಲಿ ಹೇಳಿದ್ರು ಕೂಡ ನಿಮ್ಗೆ ಅರ್ಥ ಆಗುತ್ತೆ, ಯಾಕೆಂದರೆ ಅದನ್ನು ನಾನು ಆಲ್ರೆಡಿ ಇಂಗ್ಲೀಷಲ್ಲಿ ಹೇಳಿರ್ತೀನಿ. ವಾಟ್ ಎವರ್ ಐ ಎಕ್ಸ್ಪ್ಲೇನ್ ಇನ್ ಕನ್ನಡ ಇಸ್ ಆಲ್ರೆಡಿ ದೇರ್ ಇನ್ ಇಂಗ್ಲೀಷ್, ಸೊ ಯು ನೀಡ್ ನಾಟ್ ಹ್ಯಾವ್ ಟು ವರಿ. ಆಮೇಲೆ ನಮ್ಮ ಕನ್ನಡದ ಹುಡುಗರಿಗೆ ಕನ್ನಡದಲ್ಲಿ ಹೇಳಿದಾಗ ಇನ್ನೂ ಸ್ವಲ್ಪ ಈಸಿಯಾಗಿ ಅರ್ಥ ಆಗುತ್ತೆ, ಬಿಕಾಸ್ ಇಟ್ ಈಸ್ ಅವರ್ ಮದರ್ ಟಂಗ್ ಅಲ್ವಾ. ಓಕೆ, ಸೊ ನಾವು ಆಂಪ್ಲಿಫಿಕೇಶನ್ ಆಫ್ ಲೈಟ್ ಮೀನ್ಸ್ ಇನ್ಕ್ರೀಸಿಂಗ್ ದ ನಂಬರ್ ಆಫ್ photons. If you increase the number of photons, intensity increases. This is what Einstein said. So now the question, how do you amplify the light? Sir, by producing photons. Identical photons we have to produce. That's also simple. So ಜಾಸ್ತಿ photons ಅನ್ನು produce ಮಾಡಿದರೆ ಜಾಸ್ತಿ intensity ಜಾಸ್ತಿ ಆಗುತ್ತೆ, amplify ಆಗುತ್ತೆ. So by producing more number of identical photons, we can achieve amplification. So the next question is, how do you achieve that? How do you produce photons? How do you produce more photons? For that we have to study this concept, that is now comes what is called interaction. So far I explained only what is laser. Laser is nothing but light amplification by stimulated emission of radiation. What are the properties? It is well collimated, highly polarized, highly monochromatic, highly energetic, traveling in the same direction. Okay, all these are the properties. Now how to produce laser? By means of stimulated emission, by means of amplification. What is amplification? By producing more number of photons. How to produce more number of photons? For that we should understand this concept, that is interaction of radiation. This is available in my notes. Radiation with matter. Matter means it can be in solid form, it can be in liquid form, it can be in gaseous form. To begin with, I take gaseous form only. It can be liquid also, solid also. I come to that later on. Okay, let us consider hydrogen only. Very simple, which is familiar to you. In PUC you studied. In hydrogen we have what is called energy levels. Ground state is minus 13.6. Next, first excited, second excited, third excited, like that. Okay, so in hydrogen we have various energy levels. Normally atoms will be in the ground state. To begin with, they will be in the ground state. If you incident light on the ground state, then atoms will go to higher level. So this is called absorption of light. After spending some time there, they will return back. This is emission. So excitation, de-excitation, all these things you know, you already studied in PUC. While coming back, they emit radiation. That radiation may be in Lyman, maybe Balmer, maybe Passion, bracket, Fund. You know all these things. Means the emitted light may be in the UV visible region, or visible region, ultraviolet region, infrared region also. So now, instead of hydrogen, if you take neon or carbon or helium, argon, anything you take, always there will be ground state and excited states. One ground state, many excited states. Now for the sake of explanation, I take one ground state, one excited state. I take ground state as E1, excited state as E2. There are many excited states, but I take only one. Now I have one atom here. Atom is in the ground state. Dear students, here onwards I write atom as A. Atom is in the ground state. Atom ಒಂದು ಯಾವುದೋ ಒಂದು atom, ಅದು ಹೀಲಿಯಂ ಇರ್ಬೋದು, ನಿಯಾನ್ ಇರ್ಬೋದು, ಆರ್ಗಾನ್ ಇರ್ಬೋದು, ಯಾವುದೋ ಒಂದು atom ಗ್ರೌಂಡ್ ಸ್ಟೇಟಲ್ಲಿ ಇದೆ ಅಂತ ಇಟ್ಕೊಳ್ಳೋಣ. ಈಗ ಇದರ ಮೇಲೆ ಒಂದು ಲೈಟ್ ಬೀಳುತ್ತೆ, ಒಂದು ಫೋಟಾನ್ ಬಂದು ಬೀಳುತ್ತೆ. ಯು ನೋ ಫೋಟಾನ್ ಈಸ್ ರೆಪ್ರೆಸೆಂಟೆಡ್ ಬೈ H nu. ಫಸ್ಟ್ ಸೆಕೆಂಡ್ PUC ಎರಡು ಕಡೆನೂ ಓದಿರ್ತೀರಾ, ಎನರ್ಜಿ ಅಸೋಸಿಯೇಟೆಡ್ ವಿತ್ ದ ಫೋಟಾನ್ ಈಸ್ E, that is equal to h nu, where h is Planck's constant, nu is frequency of the photon. ಗೊತ್ತಿದೆ ಅಲ್ವಾ? ಸರಿಯಪ್ಪ. Okay, now when the photon is incident on the atom, what happens? Atom will absorb the radiation. This is interaction of radiation with matter. ಇದನ್ನೇ ನಾವು interaction of radiation with matter ಅಂತ ಕರೆಯೋದು. ಸೊ ರೇಡಿಯೇಷನ್ ಬಂದ್ಬಿದ್ದಾಗ ಆಟಮ್ ಆ ರೇಡಿಯೇಷನ್ ಅನ್ನು ಸಕ್ ಮಾಡುತ್ತೆ, ಅಬ್ಸಾರ್ಬ್ ಮಾಡ್ಕೊಳ್ಳುತ್ತೆ, ಹೀರಿಕೊಳ್ಳುತ್ತೆ. ದೆನ್ ದಿಸ್ ಆಟಮ್ ವಿಲ್ ಗೋ ಟು ಹೈಯರ್ ಲೆವೆಲ್. ಸೊ ದಿಸ್ ಈಸ್ ಕಾಲ್ಡ್ spontaneous absorption. Okay, spontaneous absorption. Why it is called spontaneous absorption? Spontaneous anta yavag heltivi? Anything which happens ಜಸ್ಟ್ ಲೈಕ್ ದಟ್, ಸ್ಪಾಂಟೇನಿಯಸ್ ಆಗಿ ಆಗೋಗ್ಬಿಡ್ತು, ನನಗೆ ಗೊತ್ತೇ ಆಗಲಿಲ್ಲ ಅಂತ ಹೇಳ್ತೀವಲ್ಲ, ತಾನೇ ತಾನಾಗಿ ಆಗೋಗ್ಬಿಟ್ರೆ ಅದನ್ನು ಸ್ಪಾಂಟೇನಿಯಸ್ ಅಬ್ಸಾರ್ಪ್ಷನ್ ಅಂತ ಕರಿತೀವಿ. ಓಕೆ, ಸ್ಪಾಂಟೇನಿಯಸ್ ಅಂತ ಕರಿತೀವಿ. ಅಬ್ಸಾರ್ಬ್ ಆದರೆ ಅಬ್ಸಾರ್ಪ್ಷನ್ ಅಂತೀವಿ, ಎಮಿಟ್ ಆದರೆ ಎಮಿಷನ್ ಅಂತ ಕರಿತೀವಿ. ಈಗ ಲೈಟ್ ಬಿದ್ದ ತಕ್ಷಣ ಆಟಮ್ ಮೇಲಕ್ಕೆ ಹೋಯಿತು. ಸೊ ವೆನ್ ಲೈಟ್ ಈಸ್ ಇನ್ಸಿಡೆಂಟ್, ಆಟಮ್ ಗಾಟ್ ಎಕ್ಸೈಟೆಡ್. ಸೊ ಆಟಮ್ ಗಾಟ್ ಎಕ್ಸೈಟೆಡ್ ಮೀನ್ಸ್ ದಿಸ್ ಐ ರೈಟ್ ಇಟ್ ಇನ್ ದಿ ಈಕ್ವೇಷನ್ ಫಾರಮ್. ಆಟಮ್ ಪ್ಲಸ್ h nu results atom star. Star means atom is in the excited state. Did you understand? So this is one possible interaction. Actually 3 possibilities are there. First possibility is spontaneous absorption. Another possibility, the same atom after spending time in the excited state, how much time? Very short interval of time, maybe maximum of 10 power minus 8 seconds, it will come down to the ground state. It will return back. While coming down, the difference in the energy, that is E2 minus E1, is emitted in the form of photon. So that means it emits one photon. Okay, this is also called emission, and this is happening spontaneously. I call it as spontaneous emission. Understood? Spontaneous emission. And in the form of equation, I can write A star, that is equal to A, that means atom will return to ground state, A plus h nu, that means photon is released. Okay, these are the 2 possibilities. So this is what normally happens in all the gas filled tubes. For example, ನಿಮ್ಮ ಬೀದಿ ದೀಪ ಇರುತ್ತಲ್ಲ, sodium vapor lamp, street light, the same thing is happening. In street light we have filled sodium vapor, and sodium vapor is when excited by means of electricity. There we are not using photon, we apply electricity. Sodium atoms are excited, they come down while emitting yellow color. Or mercury vapor lamp, it emits white color. ಆಮೇಲೆ ಈ ಹೋಟೆಲ್ಗಳ ಮುಂದೆ, ಆಮೇಲೆ ನಿಮ್ಮ ಶಾಪಿಂಗ್ ಮಾಲ್ಗಳ ಮುಂದೆ, ಮಾಲ್ಗಳಲ್ಲಿ ನೇಮ್ಸ್ ಹಾಕಿರ್ತಾರೆ ನೋಡಿ, ದರ್ಶಿನಿ ಅಂತ, ಅಥವಾ ಟೆಕ್ಸ್ಟೈಲ್ ಅಂತ, ಅಥವಾ ಗಾರ್ಮೆಂಟ್ಸ್ ಅಂತ, ಅಥವಾ ಏನೋ ಒಂದು, ದೇ ವಿಲ್ ಬಿ ಡಿಸ್ಪ್ಲೇಯಿಂಗ್ ದ ನೇಮ್ಸ್ ಆಫ್ ದೇರ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಶಾಪ್, ಯು ನೋ. ಸೊ ಇಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಗ್ಲೋ ಸೈನ್ boards. So in glow sign boards there will be a tube. Inside the tube, okay, darshini or textile, some letter shape, for example the L. So in the form of L, the tube is in the form of L, and inside this tube neon gas is filled. When this is connected to electric power supply, okay, it starts emitting pink color. So it starts emitting pink color. So when you look at this L, it appears pink in color. Okay, so this is what the emission of light. So this is happening in all the normal gas filled bulbs. That is nothing but spontaneous emission. Spontaneously atoms are going up, coming down, going up, coming down. It will produce photons, and thus produced photons will be traveling in all possible directions. But I don't want that. My intention is not to produce photons in random direction, and also not producing equal number of photons. I want to produce more number of photons. Why more number of photons? Because I want to amplify the light. For that I have to go for another possible emission, that is nothing but stimulated emission. So the next possibility, same diagram, same energy level, okay, E1, E2, atom is already in the excited state. Atom is already in the excited state. Dear students, see here, earlier atom was in the ground state, it went up because of this, then came down, emitted this. So I lost one photon, I gained one photon. Okay, so this is no loss no gain situation, but I actually want more photons by spending one photon. If I get at least 2 from 1, it is an achievement. 3 from 1, it is better. 4 from 1, much better. 1000 it from one, much better. So I want that ಜಾಸ್ತಿ photons ಬೇಕು ನನಗೆ. I want more photons because I want to amplify the light. So now how to achieve? Coming back to this, I will explain now. Atom is already in the excited state. Within 10 power minus 8 definitely it will come, but before it is coming down, do one thing, send one photon. Before the atom comes down, send one photon. So then what happens? This photon will influence this atom. This photon will stimulate this atom. See, I am using that word, stimulate, instigate, or influence, or induce. All are same. Like for example, you take your classroom only. ಈಗ ನಿಮ್ಮ ಕ್ಲಾಸಲ್ಲಿ ಒಬ್ಬ ಹುಡುಗ ಆಲ್ರೆಡಿ ಹೊರಗಡೆ ಬಂಕ್ ಮಾಡಿ ಹೊರಗಡೆ ನಿಂತಿದ್ದಾನೆ ಅಂತ ಹೇಳಿ. ಆಲ್ರೆಡಿ one student is outside and you are sitting in the first bench. From outside only your friend is calling you, come like that. So when he calls, you also will go along with him. So that two students, yourself and your friend, both two students are going out of the class. Suppose your friend is not calling you, then you will not go. So what your friend is signaling like this, no, it is called stimulation. Hey, baro hogana anta karitanalla, adu stimulation. Come and we will bunk this class, we will go somewhere anta karitanalla, that is stimulation. Suppose if he calls you and your friend, the number of students going out becomes 3. Suppose if he call all first bench students, let us say 5 members are there, 5 plus that boy, 6 members. Ee tara number of students going out of the class becomes more. Almost same logic holds good here also. This is your friend outside the classroom and this is you sitting in the first bench and waiting for your friend, and your friend will signal you. Then this atom also will come down. Because it is coming down, it emits its own photon, and this photon will also come along with that. So thereby number of photons going out becomes 2. So this is your friend, this is the photon emitted by you. So we have 2 photons. See what happens? This photon is not absorbed. Okay, it is only stimulating, it's only instigating, it's only influencing. Because of that we are getting 2 photons. See, by losing 1 photon I am getting 2. This I want to write in the equation form. Atom is already in the excited state. Now I am sending 1 photon, therefore atom comes to ground state, but I get 2 photons, 2 h nu. This is called stimulated emission, and this is what Einstein suggested way back in 1917, and we want this particular category. I told you there are 3 possible reactions, 3 possible interactions. Number 1, spontaneous absorption, next spontaneous emission, next stimulated emission. And for laser, stimulated emission is more appropriate because this is the only possibility where I can get more number of photons. So ಇಲ್ಲಿ ಜಾಸ್ತಿ photons ಬರೋ ಸಂಭವ ಇದೆ, ಚಾನ್ಸ್ ಇದೆ, ಹಾಗಾಗಿ ನಾವು ಸ್ಟಿಮ್ಯುಲೇಟೆಡ್ ಎಮಿಷನ್ಗೆ ಹೋಗ್ತೀವಿ. ಹಾಗಾದರೆ ವಾಟ್ ಈಸ್ ಸ್ಟಿಮ್ಯುಲೇಟೆಡ್ ಎಮಿಷನ್? ವೆರಿ ಸಿಂಪಲ್ ಆನ್ಸರ್. ಈಗ ನಾವು ಫೈನಲ್ ಆಗಿ ವಿ ಲುಕ್ ಫಾರ್ ಆನ್ಸರ್. ಸರ್ ವಾಟ್ ಈಸ್ ಸ್ಟಿಮ್ಯುಲೇಟೆಡ್ ಎಮಿಷನ್ ಅಂತ ಕೇಳಿ ನಾನು ಏನು ಬರೀಲಿ? ನಾರ್ಮಲಿ ವಾಟ್ ಈಸ್ ಸ್ಟಿಮ್ಯುಲೇಟೆಡ್ ಎಮಿಷನ್ ಅಂತ ಕೇಳಲ್ಲ, ಎಕ್ಸ್ಪ್ಲೈನ್ ಸ್ಟಿಮ್ಯುಲೇಟೆಡ್ ಎಮಿಷನ್ ಅಂತಾರೆ, ಆರ್ ಎಕ್ಸ್ಪ್ಲೈನ್ ಇಂಟ್ರಾಕ್ಷನ್ ಆಫ್ ರೇಡಿಯೇಷನ್ ವಿತ್ ಮ್ಯಾಟರ್. ದಿಸ್ ಈಸ್ ಅ 6 marks ಕ್ವಶನ್. ಎಕ್ಸ್ಪ್ಲೈನ್ ಇಂಟ್ರಾಕ್ಷನ್ ಆಫ್ ರೇಡಿಯೇಷನ್ ವಿತ್ ಮ್ಯಾಟರ್. ದೇರ್ ಆರ್ 3 types of interactions, namely spontaneous absorption, spontaneous emission, stimulated emission. Sometimes we call this a stimulated absorption also. Okay, so 3 types of interactions. In first case, atom is in the ground state. When photon is incident, it goes to higher level. This is spontaneous absorption. And the reaction A plus h nu is equal to A star, because A is in the ground state, here A is in the excited state. Second possibility, spontaneous emission. The excited atom cannot stay in the higher level forever. ತುಂಬಾ ಹೊತ್ತು ಇರೋದಿಲ್ಲ. It will return to ground state within 10 power minus 8 second. While coming down, the excess energy is emitted in the form of radiation, and the reaction A star comes down to ground state by emitting 1 photon. This is the normal procedure in all gas filled bulbs, including your sodium vapor lamp. Another possibility, stimulated emission. In stimulated emission, already atom is in the excited state. Now if I send a photon of same frequency, then it will stimulate, it will disturb, it will influence the atom to undergo de-excitation. ಕೆಳಗಡೆ ಬೀಳಲಿಕ್ಕೆ ಅದು ಸಪೋರ್ಟ್ ಮಾಡುತ್ತೆ. ಆಸ್ ಎ ರಿಸಲ್ಟ್ ವಿ ಗೆಟ್ ಟು ಮೋರ್ ಫೋಟಾನ್. ಸಪೋಸ್ ಇಫ್ ದೇರ್ ಇಸ್ 1 atom I get 2, if I 2 atoms I get 3, if there are 10 atoms I get 11. Like that, more number of identical photons are emitted. This is called stimulated emission. I hope you got it. So stimulated emission is the only possibility for lasing action. It is not spontaneous emission, it is not spontaneous absorption. Spontaneous emission is for ordinary light, stimulated emission is for laser. Okay, I hope you got it. This is a basic, very basic. You take any laser, whether it is solid laser, liquid laser, gas laser, any type of laser you take, this is the main mechanism. There must be stimulated emission. For stimulated emission, there must be atom in the excited state, and not only that, you should have a photon of same frequency. Got it? Well, with this, now let me proceed further. Einstein gave a theory for this particular stimulated emission, for this particular spontaneous emission. Actually, in his theory, he insisted the necessity of one particular level called metastable level. What is this metastable level? So next heading, before I go to Einstein's theory, I explain metastable level. Meta means between, in between anta. Meta stable, not perfectly stable, not perfectly unstable also, it is in between. So I call it a metastable level, or also call it as metastable state. Dear students, just now I said ground state is highly stable. If you put the atom in the ground state, it can stay forever. ಎಷ್ಟು ದಿವಸ ಬೇಕಾದರೂ ಅದು ಅಲ್ಲೇ ಇರುತ್ತೆ. If you take the atom to higher level, okay, there it cannot stay beyond 10 power minus 8 seconds. Right? So I take, let us say there are 100 atoms here, 100 or 1000 or ಎಷ್ಟು atoms ಇದೆ ಅಂದ್ಕೊಳ್ಳಿ. There are so many atoms in the ground state. Obviously atoms will be there in the ground state. Okay, so this is the population of ground state. So that is N1. So I am going to use several terminologies here: metastable state, population. All these are the terms associated with laser. Population, population inversion, okay, pumping process, active medium, resonance cavity, gain medium. All these are the terminologies associated with laser. Metastable state antini, population inversion antini, active medium anta, resonance cavity ಇವೆಲ್ಲನೂ ಲೇಸರ್ ಅಲ್ಲಿ ಬರ್ತಕ್ಕಂಥ ಪದಗಳಿದೆ. ಈಗ ಫಸ್ಟ್ ಮೆಟಾಸ್ಟೇಬಲ್ ಸ್ಟೇಟ್ಗೆ ಬರೋಣ. ನೋಡಿ, ಇಲ್ಲಿ ಸಿಕ್ಕಾಪಟ್ಟೆ ಆಟಮ್ಸ್ ಇರುತ್ತೆ. ದೇರ್ ವಿಲ್ ಬಿ ಮೋರ್ ನಂಬರ್ ಆಫ್ ಆಟಮ್ಸ್. ಹಿಯರ್ ದೇರ್ ಮೇ ಬಿ ಆಟಮ್ಸ್, ದೇರ್ ಮೇ ನಾಟ್ ಬಿ ಆಟಮ್ಸ್. ಇದ್ರೂ ಕೂಡ ಒಂದೋ ಎರಡೋ ಇರುತ್ತೆ. ಐ ಕಾಲ್ ದಿಸ್ ಆಸ್ N2. ಸೊ N1 is always greater than N2. Suppose if I send radiation, then atoms will absorb the radiation, they go to higher level. Slowly number of atoms in the higher level increases. And that is what I want. If there are more number of atoms, then I can have more number of photons. If there are no sufficient number of atoms, then de-excitation will be less, no more number of photons. ನನಗೆ ಲೇಸರ್ ಬೇಕು ಅಂತಂದರೆ ಇಲ್ಲಿ ಜಾಸ್ತಿ ಫೋಟಾನ್ಸ್ ಇರಬೇಕು. ಸೊ ಜಾಸ್ತಿ ಫೋಟಾನ್ಸ್ ಇರಬೇಕು ಅಂದರೆ ಐ ಶುಡ್ ಕಿಕ್ ದೆಮ್. ಓಕೆ, ಸೊ ಐ ಶುಡ್ ಕಿಕ್ ದೆಮ್ ಫ್ರಮ್ ಲೋಯರ್ ಲೆವೆಲ್ ಟು ಹೈಯರ್ ಲೆವೆಲ್. ಸೊ ದೀಸ್ ಆರ್ ದಿ ಆಟಮ್ಸ್ ಇನ್ ದ ಲೋಯರ್ ಲೆವೆಲ್, ಸೇ N1. ಇನ್ ದ ಹೈಯರ್ ಲೆವೆಲ್ ದೇರ್ ಮೇ ಬಿ, ಮೇ ನಾಟ್ ಬಿ, ಇದ್ರೂ ಕೂಡ ಒಂದೋ ಎರಡೋ ಇರುತ್ತೆ. N1 ಈಸ್ ಆಲ್ವೇಸ್ ಗ್ರೇಟರ್ ದ್ಯಾನ್ N2. ಬಟ್ ಐ ವಾಂಟ್ ಮೋರ್ ನಂಬರ್ ಆಫ್ ಆಟಮ್ಸ್ ಇನ್ ದ ಎಕ್ಸೈಟೆಡ್ ಸ್ಟೇಟ್. ಇಲ್ಲಿ 1000 ಇದ್ರೆ ಇಲ್ಲಿ ಒಂದು ಸ್ವಲ್ಪ ಅಷ್ಟೇನೆ, ಇಲ್ಲಿ ಜಾಸ್ತಿ ಇರಬಾರದು. ಓಕೆ, ಮೇ ಬಿ 1 or 2. ದಟ್ ಮೀನ್ಸ್ ಐ ವಾಂಟ್ ಅನ್ ಅಬ್ನಾರ್ಮಲ್ ಸಿಚುವೇಶನ್ ವೇರ್ ಇನ್ N2 ಈಸ್ ಗ್ರೇಟರ್ ದ್ಯಾನ್ N1. ದಿಸ್ ಈಸ್ ವಾಟ್ ಐ ವಾಂಟ್. ಬಟ್ ನಾರ್ಮಲಿ ದಿಸ್ ಈಸ್ ದ ಸಿಚುವೇಶನ್. ದಿಸ್ ಈಸ್ ಎ ನಾರ್ಮಲ್ ಸಿಚುವೇಶನ್. ಐ ವಾಂಟ್ abnormal situation. This abnormal situation is called population inversion. So this is also one important question. What is population inversion? It is an abnormal situation in which higher levels are more populated than lower levels. That means there must be more number of atoms in the higher level than in the ground level. So this is an abnormal situation, and that is what is called population inversion. Now the question, how to achieve population inversion? Only by sending the radiation, or only by giving the energy. That means you have to literally pump them. Okay, you literally ಪಂಪ್ ದೆಮ್. ಕೆಳಗಡೆಯಿಂದ ಮೇಲಕ್ಕೆ ನೀರನ್ನು ಲಿಫ್ಟ್ ಮಾಡ್ತಿರಲ್ಲ, ಆ ಥರ ಲಿಫ್ಟ್ ಮಾಡಬೇಕು. ಯು ಹ್ಯಾವ್ ಟು ಪಂಪ್ ದೆಮ್. ಓಕೆ, to pump them we need some energy source, and that energy source is called pumping source. Okay, so I will come to that pumping later on. So metastable state. So when you pump them, they will go to higher level. Within no time they will fall down to to ground state. But I want to achieve N2 greater than N1. If at all you want to achieve N2 greater than N1, that means if at all you want to have more number of atoms here, achieve it within 10 power minus 8 second. Within 10 power minus 8 second ಒಳಗಡೆನೆ ನೀವೆಲ್ಲ ಆಟಮ್ಸ್ ಅನ್ನು ಕಳಿಸಬೇಕು, ಅಷ್ಟು ಫಾಸ್ಟ್ ಆಗಿ ಕಳಿಸಬೇಕು. ಬಟ್ ಇಟ್ ಈಸ್ ಪ್ರಾಕ್ಟಿಕಲಿ ನಾಟ್ ಪಾಸಿಬಲ್. ಈಗ ನೀವು ಒಂದು ಆಟಮ್ ಅನ್ನ ಕಳಿಸಿದ್ರಿ, ಇನ್ನೊಂದು ಕಳಿಸೋ ಅಷ್ಟೊತ್ತಿಗೆ ಇದು ಕೆಳಗಡೆ ಬಿದ್ದೋಗ್ಬಿಟ್ಟಿರುತ್ತೆ, ಇನ್ನೊಂದನ್ನು ಕಳಿಸೋ ಅಷ್ಟೊತ್ತಿಗೆ ಇದು ಕೆಳಗಡೆ ಬಿದ್ದೋಗಿರುತ್ತೆ. ಬೈ ದ ಟೈಮ್ ಯು ಟೇಕ್ ದಿಸ್ ಒನ್, ದಿಸ್ ವಿಲ್ ಕಮ್ ಡೌನ್. ಬೈ ದ ಟೇಕ್ ದಿಸ್ ಒನ್ ಅಪ್, ದಿಸ್ ವಿಲ್ ಕಮ್ ಡೌನ್. ಲೈಕ್ ದಟ್, when you keep exciting the atoms, atoms will come down also. That means it is impossible to achieve N2 greater than N1 in the upper level because they are short lived. The lifespan is very small, about 10 power minus 8 second. So what to do? There is a solution. There is a solution. In some materials we have one intermediate level. We have one intermediate level where if an atom is put, it will stay somewhere between 10 power minus 5 to 10 power minus 3 second. Even 10 power minus 5 is also sufficient. 10 power minus 5 compared to 10 power minus 8 is 10 power 3. That means 1000. What I mean to say, if an atom can stay here for 1 second, here it will stay for 1000 second. Or in general, whatever the time it spent here, 1000 times more time it will spend here. That is sufficient for us. 1000 times ಜಾಸ್ತಿ ಹೊತ್ತು ಉಳಿಯುತ್ತೆ, ಅಲ್ಲಿ ಕೂರುತ್ತೆ ಅನ್ನೋದಾದರೆ that is enough for us. That means this level is neither 100% stable nor 100% unstable. It is in between. Compared to this, it is unstable only. But compared to this is stable. Such state is called metastable state. So what is a metastable state? It is energy level whose lifespan is between 10 power minus 5 to minus 3 second, and atoms can stay there for considerable amount of time. This is metastable state. It lies between ground state and excited state. ಕೆಲವೊಂದು ಮೆಟೀರಿಯಲ್ಸ್ ಅಲ್ಲಿ ಈ ತರದ ಕಾನ್ಫಿಗರೇಷನ್ ಇರುತ್ತೆ, ಎಲ್ಲ ಮೆಟೀರಿಯಲ್ಸ್ ಅಲ್ಲ. It is not in all the materials. In some of the materials we have this metastable state configuration. Okay, so now if you excite the atoms, some of them will come here, some of them will go here. Okay, you keep on pumping them. If you keep on pumping them, some will come down ground state, some will go and stay here, and they won't come out immediately. They won't come down immediately because they have some leisure time. ಸ್ವಲ್ಪ ಟೈಮ್ ಇದೆ, ಸೊ ಹಂಗಾಗಿ they relax there. ಸೊ ಅಲ್ಲಿ ಸ್ವಲ್ಪ ಕೂತ್ಕೊಂಡು ರೆಸ್ಟ್ ತಗೊಳ್ತವೆ. ಆಫ್ಟರ್ ಸಮ್ ಟೈಮ್, ಸ್ವಲ್ಪ ಹೊತ್ತು ಆದಮೇಲೆ the number becomes more and more and more. So now I take this number as N2 and this number as N1. Definitely N2 will be more than N1. That means I am achieving population inversion. So come on, tell me where I am achieving population inversion. Yes, you are correct. It is in the metastable state. So in the metastable state, population inversion is achieved. So now you got the importance of metastable state. This is what Einstein proved in his theory, which I am going to discuss in the next video. That is one of the important question. You can expect that for 10 marks. Okay, so ನೋಡಿ ಇಷ್ಟು ಈ ವಿಡಿಯೋದಲ್ಲಿ ನಾನು ಹೇಳಿರೋದ್ರಲ್ಲಿ ನೀವು 3 ಕ್ವೆಶ್ಚನ್ಸ್ ಅನ್ನು ಎಕ್ಸ್ಪೆಕ್ಟ್ ಮಾಡಬಹುದು. ನಂಬರ್ 1, ಮೆನ್ಷನ್ ದ ಕ್ಯಾರೆಕ್ಟರಿಸ್ಟಿಕ್ಸ್ ಆಫ್ ಲೇಸರ್. Number 2, discuss the interaction of radiation with matter. Number 3, define metastable state, population inversion, pumping process. Okay, so these are all very simple and all these details are available in my notes. Anyway, I will come back to you with my next video. In the next video, Einstein's theory of A and B coefficient ಅಥವಾ Einstein's theory of laser. Okay, so with this I stop this video here. ತುಂಬ ಲೆಂತಿ ಆಗೋದು ಬೇಡ, 40 minutes ಕೂಡ ನನ್ನ ದೃಷ್ಟಿನಲ್ಲಿ ಜಾಸ್ತಿನೇ. Okay, so I will upload short videos only. In each video maybe 1 or 2 full questions I am going to cover. Dear students, please support me, keep in touch with me, keep supporting me, keep watching my channel and also spread my channel among your friends. So ಬೇರೆಯವರಿಗೂ ನೋಡಲಿಕ್ಕೆ ಹೇಳಿ ನನ್ನ ಚಾನಲ್ ಇಂದ ನಿಮಗೆ ಬೆನಿಫಿಟ್ ಆಗುತ್ತೆ. ನೋಟ್ಸ್ ಎಲ್ಲ ಹಾಕಿರ್ತೀನಿ ಡಿಸ್ಕ್ರಿಪ್ಷನ್ ಬಾಕ್ಸ್ ಅಲ್ಲಿ, PDF ಅದನ್ನು ಡೌನ್ಲೋಡ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಆಮೇಲೆ ಒಂದು ಮಾಡ್ಯೂಲ್ ಕಂಪ್ಲೀಟ್ ಆದಮೇಲೆ ಪ್ರೀವಿಯಸ್ ಇಯರ್ ಕ್ವೆಶ್ಚನ್ ಪೇಪರ್ಸ್ ಅನ್ನು ಸಾಲ್ವ್ ಮಾಡಿ along with numericals, that also I will upload. Okay, thank you very much.